Alright, in this video, we will answer a problem in Vapor Compression Cycle. Okay, first let's write our given. What do we have? For this problem, we are required to find a certain number of marami siyang pinapahanap. So, let's write our given. We have the mass ng water, 45,000 kilograms, that has an initial temperature of 29 degrees Celsius na gagawin natin, palalamigin natin sa 18 degrees Celsius in a time span of 5 hours. Okay. Now, the working refrigerant that we have for this cycle is ammonia or NH3. Okay, so it's important na first identify natin kung anong refrigerant. Tapos, buklatin nyo na agad sa ref table nyo kung ano yung nararapat na table for that refrigerant. First, let's draw its pH diagram or the pressure enthalpy diagram. Slightly leaning to the right. Yan. And then we have here, let's draw. Yan. So, let's write our point. We have here point 1, 2, 3, and 4. Dito sa baba is our heat added and sa taas is the heat rejected. Then here we have our work input from the compressor. Okay, we can now proceed. Una natin gagawin is to find the enthalpies. Once we find the enthalpies, magiging madali na. So our pressures are 616 kilopascal for the evaporator and 1737 for the condenser. Those are in kilopascal. So let's proceed. First, punta tayo kay point 1 which is sa evaporator. So we have the pressure of the evaporator 616 kilopascal. And at that point, our refrigerant is what? The saturated vapor. So from your ref table, we will since wala dong sakto na 1616 kilopascal, we will interpolate. So, base from your ref table, we have here 615.2 and 728.6. Nasa gitna nila yung 616. So, lagay lang natin yung corresponding Hg nila. So, using your calculator, you'll find that H1 is equal to 1452.3 kilojoules per kilogram. At store mo na agad yan sa A or sa kahit anong variable na gusto mo. Again, ginamit lang natin yung calculator natin dyan. Okay. Mode 3 to yon. At kailangan din natin to find the entropy to find H2 later on. Okay, so using your calculator again, mode 3 to nag-interpolate lang tayo. Hindi ko na nasulat dito but you can just base every value sa ref table. So this is obtained through interpolation. Next, we can now proceed to point 2 which has a pressure of 1737 kilopascal. From here, base from our ref table, wala tayong makikitang sakto na 1737 kilopascal. So, we'll find a range that where 1737 will lie. So, nasa pagitan siya ng 16 at 2000 and take note, it's superheated ammonia. So, punta ka sa superheated ammonia table mo, hindi dun sa saturated. So, una sa 16 kilopascal, lagay din natin yung kung saan pumagitna yung 5.2041 na nakastore sa B. So, writing the necessary values sa corresponding enthalpies of each entropy, gawin din natin siya for the 2000 kilopascal. Again, we need the entropy and the enthalpy. Be sure to write the proper values. Recheck, always recheck. Okay? So, we have here our H21. So, using your interpolation, mode 3.2, you will arrive with 1586.2218, and for our H22, sa 2000 kilopascal, you'll get a value of 1621.9087. So, store mo na yan sa C and store mo na yan sa D. And then, makukuha na natin our enthalpy at point 2 using the values we've obtained. So, kailangan natin yung enthalpy sa pressure na 1737, our H2, using your calculator, mode 32, interpolate, that's y hat. So, 1737 y hat will give you 1598.4446 kilojoules per kilogram. Alright, we now have our enthalpy at point 2. Isa na lang yung kailangan natin. Because our H3 is also equal to our H4. So, again, sa pressure at the condenser, 1737 kilopascal, we will now go to the HF or the enthalpy at the saturated liquid line. Okay, so, inputting the necessary values, pumagit na yung 1737 sa dalawang pressure na to. Lagay lang natin yung corresponding HF nila. And sa gitna yung hinahanap natin na H3. Our H3 is HF and it is also equal to H4. We'll get 391.38 kilojoules per kilogram. Store mo na yan sa C. Okay? Now we have our enthalpy at points 1, 2, 3, and 4. So, madali na nating makukuha yung mga values or mga pinapahanap in this particular problem. So, first, let's write down para organize yung solution natin at hindi tayo maligaw sa pagpindot. Our H1 is 1452.0303. Our H2 is 1598.4446. And our H3, H4 is equal to 391.38 kilojoules per kilogram. Again, yung H1 ay nakastore sa A, H2 ay nakastore sa B, at si H3 at 4 ay nasa C. Okay, alright. Now, let's proceed. Ang unang pinapahanap is the coefficient of performance or our COP. Our COP is equal to our QA over work-in, or simply in terms of enthalpy, H1 minus H4 over H2 minus H1. So, ang pipindutin mo na lang is yung naka-stored values. So, A minus C over B minus A will give you 7.2242 for your COP or coefficient of performance. So, up next, pinapahanap sa atin is the quantity of cooling water in the condenser for an increase of 7 degrees Celsius. So, hindi natin siya basta-basta mahanap kasi wala pa tayong we still don't have the mass flow rate of our refrigerant. So, kailangan muna natin hanapin yung mass flow rate ng refrigerant, and we can use yung given sa atin kasi we will need to cool water. Is that water or ice? Yeah, water. So, palalamigin natin yung water. So, okay, we can first obtain our QA. And from our QA, we can find our mass flow rate of the refrigerant. So, the mass of the water is 45,000 kilogram. Palalamigin natin siya within 5 hours. Just convert that to seconds. And the CP of water is 4.187. Then from 29, gagawin nating 18. Simply higher minus lower lang yung ginagawa ko. Then you'll arrive with 115.1425. So you have here your QA. And from here, we know that QA is equal to the mass of the refrigerant times H1 minus H4. So simply QA over A minus C. Unit analysis, matitira dyan is kilogram per second. Your mass flow rate of the refrigerant is 0.1086 kilogram per second. Then, store mo yan. Ginawa ko, I'd store that in number 1. Okay. Now, we can now find the mass of the cooling water using principle of heat transfer. Yung heat na i-absorb ng cooling water ay equal sa heat na i-reject ng condenser. So, we simply equate their heat. So we have here MCP delta T is equal to M delta H. So makukuha na natin si M sub CW or mass of the cooling water. So again, naka-stored values tayo. So Just input the necessary values and change ang temperature is 7 degrees Celsius. CP ng water is 4.187. So makukuha mo, mass of the cooling water is approximately equal to 4.4709 kilograms per second. Next, we are asked to find the compressor power or the work input by our compressor, and it is simply the mass flow rate of our refrigerant times H2 minus H1. So, again, just input your values. Pag nakuha na natin ang enthalpy, madali na lahat. So, you'll arrive with 15.8945 kilowatts. This is the work input of our compressor. Alright, so lastly, we are asked to find the volume flow rate entering at the compressor. So the volume flow rate entering the compressor is the volume at the outlet of our evaporator. So the volume flow rate is the mass flow rate over density or mass flow rate times our specific volume. Again, we will find the volume flow rate at the outlet of the evaporator kasi yun yung papasok sa inlet ng compressor natin. And at the evaporator, we have saturated vapor. So, V sub G. So, again, ang pressure is 616. Yung dalawang pressure na pumapagitan doon, just input the corresponding V sub G. And using your calculator, mode 32, that is 616 Y hat, you'll arrive with Vg is equal to 0.2052 cubic meters per kilogram. So, store mo yan sa kahit saan. I used number 2. Then, we can now find our volume flow rate. Simply, mass flow rate ng refrigerant times V sub G. So, stored values, you'll arrive with cubic meters per second. Our volume flow rate is 0.02228 cubic meters per second. Alright, so that is our volume flow rate of the refrigerant. Okay, now that we find all the necessary na nawawala in this problem, okay, we have your COP. So, that's all for this problem in vapor compression cycle.